So we are done with the course introduction and we are ready to learn about some special TypeScript types. In this new section of our course, what we will cover right here. First of all, we will learn about the types in JavaScript and how also TypeScript supports them. We will learn about arrays, function, some special types like any and unknown. We will learn about the TypeScript feature called type aliases. Basically, we can write our own types. And in the end of this section, we will have a short practice lecture, a small greeting application. Let's see how our workspace will look by the end of this section. This is our workspace and these are the files that we will be working on. You can take them from the course resources. We will go through each one of them and we will learn some great TypeScript features. This being said, let's get to work. First of all, let's get over the basic JavaScript types. They are called primitives and they are the building blocks of all the data inside our projects. Well, they are like I wrote a little primitive types inside our basic program. And what's cool about it is that if you're using VS Code or any other modern editor, you will see that if we populate these values, and if we then hover over them, we will see their exact types. Because this is something called type inference. We are giving a value to our variable, and then TypeScript will directly know its type by looking at the value of our reference. For example, we have here the first name, which is John. We have a boolean value, is admin. We have an age, which is a number. And basically these are the most common used values and the most common types inside the JavaScript and TypeScript. Then we have some duties, and this is something called an array, which is a collection of multiple elements. If I hover over it, you will see that this is of type string array. If there's something interesting, if I will add here like a number, and I will save this, you'll see now this is of type array of either string or number. We will talk in detail about this kind of types, these union types they are called, but we will talk about them later in the course. We have also two other types that represent the absence of values. For example, our employee John, he is at the start of his career, he doesn't have too much things, so he doesn't have a car and he also doesn't have a bicycle. These null values represent the absence of a value. And then another building block of JavaScript are the functions. And there are two ways in which we can express functions. If you didn't work with JavaScript until now, maybe this way of looking at the definition of a function is a little weird. Basically, we have a reference, the work, and then this is the implementation of the function. Again, if I go with the mouse over my function, you will see that this is of a function that returns void. You will see what is printed when we will print these values of these items. We have two newer additions to JavaScript. These are the big integer. You will see this is the big integer. Our employee is at the start of his career, but he is at a great company, so he has a very big salary. And there's also one new type inside the JavaScript in the latest versions. This is a symbol, which is a value guaranteed to be unique. Well, we already have a compilation error because it tells us that big int literals are not available when targeting lower than ES 2020. So in order to fix this issue, I will just go to the tsconfig file and here I will select a newer target. I will select here ES 2020. And then we won't have an error right here. In the end, right here, I put all these values inside an array, and then I'm iterating over this array. And let's use this very important operator. This is an operator that comes from JavaScript. And this is an important point. When you are learning TypeScript, TypeScript is an addition to JavaScript. So in the beginning, you won't know exactly what is a JavaScript feature and what is a TypeScript feature. The easiest way in which you can find out is to just compile or transpile your code and analyze the generated code. This way you will know exactly what is TypeScript and what is JavaScript. This type of operator is belonging to JavaScript, and let's see how this is working. I will execute this program using TS node, and let's see what is the type of all these items that we just put right here. So here I will say right here, I will execute this directly with TS node src. Alright, and let's analyze this. As you can see, John is string, false is boolean, 30 is number. This is interesting. Null is object. So null values inside the JavaScript, they are perceived as objects. Well, also undefined is undefined. This array, if we look upstairs, this array right here, arrays are still objects inside the JavaScript. Functions are functions, big int is big int, and symbol is symbol. Where these are the basic JavaScript types, and TypeScript also adds a few additional basic types. These are the types that also TypeScript brings newly to the table: the any, unknown, never, the arrays, the tuples, and the enums. We will talk in detail about each of them throughout the course when we will encounter them. Well, we quickly saw in this lecture the JavaScript primitive types. We saw that TypeScript infers those types by their values, and what's very important about these values, if now we have this age which is of type number, we can't just say at this point age is a string. At this point we will have a compilation error because age is not a number is not assignable to string. Well, this is a type safety that TypeScript brings new to the table, and this will prevent a lot of errors. Let's move on into the next lecture and talk about TypeScript arrays. Now let's talk about arrays in TypeScript, but we will start this lecture with an annoying warning or error from VS Code and TypeScript, and this one comes from, when you are learning and you have the same constant name over multiple files. Well, VS Code and TypeScript don't like this. It tells us that we can't redeclare this constant because we used it inside the last lecture file in the primitive types. Well, there are multiple ways in which we can solve this annoying warning, especially if we are learning. The easiest way to solve this is to just make this file a JavaScript module, and we will have a dedicated section in which we will talk about referencing code around inside our project, a section dedicated to modules. But for the moment, let's talk about arrays. Well, there are two ways in which we can declare arrays or type arrays in TypeScript. If we already gave a value to this array, let's say that we have here the duties of our employee, and we can see that these duties are of type string array. Well, there's another way in which we can declare the type of this array. We can just say right here, array of string, and this is the exact same thing. If I hover over it, you will see that this is again a string array. This is something called a generic, and again we will talk in detail about them when the time is right. But for the moment we see that we have these arrays, and what I want to quickly show you, is that we can do in JavaScript multiple options on array. For example, if we have these duties, we can call something like this. We can call different methods over them, and the most important shortcut you will use with TypeScript is control space, and with control space it will give you the available options that you have in that exact point where your cursor is. For example, here we are watching over the methods of our array. We can call an array, we can add an element, and let's just add a new duty for our employee. Let's just say right here, fix bugs. Alright, and another option that we can do with array is call different methods for different elements inside this array. For example, here we have a map function that requires another function that will be run for each element inside this array. And if you are learning TypeScript, you know this hovering over types, it will be of great values. What I want to emphasize right here, if we have an array which is of type string array, then we will call an callback for each element. TypeScript will directly know that this element is of type string because here we have a string array, and we can directly call a method from string inside the body of this callback. Well, this is in short JavaScript arrays. Of course, they are much more complex. I only wanted to show you the TypeScript part. And another important type that TypeScript adds to these arrays are the tuples. Here we have, for example, a local code for each array, and these tuples are like a fixed length array that can hold multiple types of data. For example, this tuple can hold string and number values. If I will remove this type annotation right here, then TypeScript will directly infer this from the values that we pass right here, but this is something different. This is an array that can even hold numbers or strings. But if I infer this, or if I specify directly this type, then this value can't hold any other values. If I will try to declare a new value when I'm declaring this tuple, I will get a compilation error. You know, it will tell me that these types are incompatible. Well, there's a problem with TypeScript. As you can see, even if we are declaring this a tuple which can hold only two elements, currently TypeScript allows us to push again elements to this tuple, and this won't be an error. You know, this is an error right here, but if I push later on this element, this is not an error. Well, this is a small problem in TypeScript. Anyway, tuples are not so widely used. We can have other more complex types that we can use for our data. Let's move on to the next lecture and talk about functions. In this lecture, we will talk about functions, and it is important for you to understand how functions, and especially for how TypeScript types work inside functions, because functions are the place where we will use mostly TypeScript. And what I mean by that, you have currently the privilege to look at the dumbest function ever, and besides that it also has a compilation error. Well, we have a function which receives an argument and returns hello plus that argument. Currently we have a compilation error that tells that parameter name has implicitly any type. Well, because we didn't specify here any type, well, it says TypeScript understands that this is of type any, and currently our compiler options don't allow us to have this implicit any. If we will go to our TypeScript configuration, our tsconfig.json, and I will allow this no implicit any, I will make this false and save this, you will see that now we won't have a compilation error, but still VS Code will again give us a warning telling us that this name has an any type. Well, let's switch back to this no implicit any to true, and let's give this argument a value. Let's make this a string. And what is important about this function? As you can see, all the functions have some types inside their signature, what their parameters are, and also all the functions have a return type. In our case, our functions returns a string even if we didn't specify it ourselves, because here we are returning a string concatenation, then it will for sure return string. We can directly specify this by calling this string again, but this is somewhat redundant, especially for very simple values. If you have much more complicated return types that it is important for you to specify them. If we are working with primitives in our case, maybe we can just let TypeScript infer the return type of this function. Well, if we will call this function, you can see that this John grid constant has now type string because it infers it from the return type of our function. Well, we also can have multiple ways in which we can handle our arguments. For example, if we know that our function argument is of type string, then inside our function body we will be able to call different string options or different string methods right here. Maybe call the uppercase hello grid. Also, JavaScript has an interesting feature called optional parameters. For example, here we have this console grid John function, and what is interesting about this function, if I hover over it, you will see that now its argument will be of type string, but you will see that this has an optional modifier. This question mark indicates that the parameter to this function is optional. And why is that? Because if it will be missing, it will be directly have like a default built-in value. So we can call this function, I can say right here, console grid John without any parameters, or I can call here console grid John with maybe other parameters, you know, something like this. And this way, because at this point this parameter to this function is optional and it has a default value. And inside the function, notice inside the function declaration right here, this parameter is of name question mark, but inside the function body this parameter is of type string. You know, we are sure that this is of type string and it is not missing from our function. Later on we can observe a different way in which we can write our functions, and this is of course a little strange if you are used to other programming languages like Java or C#. This looks a little strange, but no problem. This is exactly the same thing as we did before. This is just a different way in which we can declare a function, you know, with an this is called an arrow function because of this sign right here. This is exactly like the other ways, but we are declaring it in a different way. And the last point which I want to emphasize is by having multiple parameters to our function. For example, right here we have a function called grid multiple, and this grid multiple function, as you can see, it can access a wide range of parameters. It can have 0 parameters, 1 or 2 or infinite parameters. And observe the type of these parameters. This is a string array, and this is called the spread operator, or the var arguments inside other programming languages. And this function can receive any number of arguments with the condition for them to be string. So we can call them by just one parameter or by 2 parameters or so on. Inside this function, what's important, these names are a string array. So of course we can call array methods inside it. Well, we saw in this lecture a quick way in which JavaScript and JavaScript functions work and are declared, and what TypeScript adds to the table, of course, cool types. Let's move on into the next lecture and talk about an interesting feature of TypeScript, the any type and the unknown type. Let's now talk about 2 important special types in the TypeScript, and they are any and unknown. First of all, what is any? If we look at the code I just have right here, you will see that we can use this any type that we can add to a variable to completely disable its type checking. For example, here we are declaring this query result, which is of type any, and then I'm assigning it a number, but without any problems I can assign to it a string or an array or absolutely anything else, because if I added this any right here, I completely disabled the type checking system. Well, the next logical question is, why would I want to do this? Why would I want to just disable TypeScript when I'm using TypeScript? It makes no sense. But you will encounter or sometimes you will encounter some situations in which you won't have any types. And those situations will be, for example, when you will access data across other systems. For example, you will have a service, a web service, which gets data from outside and returns a result. Well, at that point, you have no idea what exactly was returned, if it what you expected or not. A function that in a JavaScript function that returns any inside TypeScript is JSON parse. This JSON parse just takes a string and returns a object from that string. It can throw an error if that string is not a valid JSON, or it can return a valid result if that string is a valid JSON. Either way, we have no idea what exactly it will return. So even TypeScript in the type annotations will tell us that, hey, this function returns any. It's just an example. Well, now I can have a result right here. I can have, for example, a salary. Let me say that I have now the salary which I got from an external service. Let's say that the salary is very secret and we need a secure service for it. We can't just have it inside our own code base. Well, here we have the function get salary from external service. We are passing the employee ID and we are returning back a result. Well, this salary is of type any. Well, at this point I can do anything without this salary, or better said, I can't do nothing, because I can't just, I can take right here, I can access any option right here. TypeScript won't complain. Well, there's a better alternative to handle these cases, and here I'm talking about the next special type in TypeScript, which comes to solve these problems. And when I usually take something from outside and I have no idea what I'm expecting, TypeScript has a special type called unknown. And this is a much better solution, because at this point I again have this salary, which is of type at this moment is an unknown, but now I can't just say here, right here, salary like this, because it will complain that this property that I'm trying to access inside the salary object might not exist. I'm not sure if this exists inside this object, because at this point this object is unknown. Well, what is the meaning of all of this? Why would I want to have unknown right here? Well, unknown will force me to do something called type narrowing, and let's do this right now. Well, for example, I can use the type of operator that we saw before from JavaScript, and now I can make this check. Hey, if this salary, which in this moment is unknown, its type is number, then inside this if clause, the type of this salary will be number, and I can access number operations inside it. The same with string. If the type of salary is, at this point, string, then I can, inside this if case, call string methods for it. It makes much sense, and this technique is called type narrowing. I'm taking something very wide and I'm narrowing it to the exact type which I'm expecting, or which I can expect. Well, I can go further on, and this will be a more wider type narrowing. For example, here I can check that the type salary can be either string or it can be number. So inside the if clause, my salary will be either string or either number. So the functions that I can get from this are the functions that are common to either string or number. And this is great. This unknown type will force us to handle all the edge cases and prevent errors inside our code base. I will show you one last type of type narrowing, the most complicated one. Well, let's see this complicated if clause, and as you can see here, I'm making like 1, 2, 3, 4 checks before I can, for example, do an operation on this object. Let's say that maybe my salary object has a history. I'm trying to access an external service about the salary of an employee, but maybe some employees have inside our database their salary history. Well, in this case, if my salary is at this point unknown, if I want to access different fields inside it, I can make different checks. For example, in the first check, my salary is of type unknown. Well, this is called a truthly check. So if I'm going to this check, I'm trying to make sure that this object is not undefined. If I go to the next level, you will see that at this point I get something that is not an undefined or null object. If I go further on in the next level, I can see that this salary is of type object. And further on, I can see that this salary, and this is a little more complicated, this is a generic type, but you will see it's not so hard. Basically, this is saying that this salary object has a history field. And in the end, I can check that if this history is of type array. So at this point, if I will hover the type of this history, I will see that this is of type array, and then inside the if clause, TypeScript will let me call array methods inside this salary history object. Well, this is something called type narrowing. We will have a dedicated section just to it, but you saw how the unknown type helps us. Well, one final question is when to use any. Well, we can use any type when we are migrating a JavaScript project to TypeScript. Initially, we will have any everywhere, but we will start to add types and we will remove those any references. Well, I also use any inside unit tests. We will see this in the dedicated section regarding testing. Basically, inside unit tests, we can have functions which expect complicated objects, but we can just use that any type to pass anything inside that function. Well, we saw in this lecture how to use the two special TypeScript types, the any and the unknown. Let's move on to the next lecture and talk about the most important TypeScript feature, type aliases. Well, it's time for us to talk about the most important TypeScript feature, that is the type aliases. And we express them by using the type keyword. And in the first 2 years which I programmed in a TypeScript project, I always thought that these are types, not type aliases, but yes, they are called type aliases. And basically they define the shape of an object inside our program. For example, here we have a union type, and we will talk in detail about union types in the next section. But basically, we want to express a way in which we have different positions inside our company. Currently, we only have two kinds of positions, a programmer or a HR. And we can now use this type position to add it to a constant or a let variable. And now, if I will say right here, const my position of type position, VS Code will also be kind enough to show us the two options that we have. I am a programmer, so I will select right here a programmer. If I'm not careful, and I will add the typo right here, then I will directly have a compilation error. And basically, this is like catching like almost half of bugs before runtime. This is the beauty of TypeScript. Well, using types we can define the shape of more complex objects. For example, here we have a type, a colleague. Let's just say that we want to define our colleagues. We want to think what are their characteristics. Well, let's say that our colleagues have a name, an age, a position, and a greetback function, which is an optional parameter. This means that this function can either be an option or an undefined. Well, and by using this type, now we can build our objects by matching this shape. So using this type colleague, now I can construct a new field, for example, my colleague, with a name which is string, an age which is number, a position, and a position which is a string, either programmer or HR. I can also define types not by just having a predefined type right here. I can say const my other colleague, and then I can define on the fly its type right here. And notice this type is different from the other colleague. It doesn't have a greetback function, but it has a tasks function. You know, my other colleague, and I have specified its type right here inline. Well, let's also define other types. For example, I have right here an other colleague, and I called this my Toki colleague because, you know, he has implemented this greet back function. You know, I have my Toki colleague which has a greet back function which will just say hello back when we will say hello to him. Well, we can use these type aliases inside function definitions. And let's say that we have a function definition called greet colleague which accepts a parameter of type colleague. And here I can just say inside this function body I can access the parameters or the fields of my colleague. For example, I know for sure that this colleague has a property called name. Yet again, I can make a check, and if this colleague has the greet back option, then I will just access this function right here. Let's see how this is working, and let's call this function. And then I can call this function with my colleague. For example, I can call greet colleague with my colleague right here. This is the one. Very important. I can call this function greet calling with my other colleague, which is not specifically of type colleague. And this is a very important point right here. This function will accept objects which are of type colleague. But for example, this my other colleague, we didn't specify that this is of type colleague, but because this object has the same fields, it has a name, an age, and a position field, this means that this object is also of type colleague, and my function will just accept it. Let's see how this is working, and let's just execute this code. Let's just execute this code right here. Yeah, we need to save first, all right. Alright, and as you can see, here we have accessing our function, and in the end, if my colleague has a valid greet back function, we will also execute this function. Well, in this lecture, we just scratched the surface of this important TypeScript feature, the type aliases. In this course, we will have dedicated sections only to types, and you will see that this type system of TypeScript is very, very complex. In the end, we saw that we can use types in order to define the shape of our object. One final point about TypeScript types is that they don't exist at runtime. This means that here we are using this TypeScript types, we are defining our types, and then we are adding our type annotations. But if we will compile this code, let me call TSC right here, and let's generate the JavaScript files, and let's inspect these JavaScript files for all our files. Let's just use at these types that we just defined right here. And as you can see, if we take this side to side, you'll see that all the types that we defined using TypeScript are not existing. You know, we have just the constant declarations and the function declarations right here, and then only the function invocations. So in JavaScript, our types won't exist. They only exist until compile time. This is a very important point where you will want to dynamically find out the type of a object. This is an important point which we will discuss in the next section. For the moment, you should understand that types are very complex, but they only exist inside our TypeScript files until we compile our code. Once our code is compiled to JavaScript, our types are just gone. Let's now proceed to the next lecture when we will have a practice project. In this lecture, we will practice some points that we learned until now by creating a simple TypeScript project, a simple employee manager file that will do three things. We will have a employee type, we will build ourselves an employee type, we will create a function that will assign random IDs to our employees, and we will create a function that will iterate through our employees and send them a little welcome message. Of course, we will just print that text to the console. But by doing this dump application, we will understand some very important points regarding how TypeScript works together with Node.js, and we will understand better how the type system works under the hood. Let's get to work, and the first step that we need to take, had the typo right here, the first step is to initialize a node project for us to be able to install types. You will see in a moment. Well, initializing a node project, it's a very simple step. Let's do it right now, and I need for this a terminal. Well, I'm inside this folder assigned to this section, the section 2. Well, inside this folder, using the terminal, I will call npm init -y, and this will create a package.json file. Well, this package.json file defines it defines many important points regarding our project, for example, our scripts, but also it defines our local imports, because we will need them in a moment. Well, we have our package.json file. Let's now create our employee manager file. So inside our source directory, we'll create a new file where our great employee manager file, and this is the file that will hold our functionality. First of all, let's create a simple type, and let's think about what is required for our employee. Of course, he needs a name and an ID. Well, let's also assign to him an email and a salary. Well, this being said, we know how our object and how our employee type will look like. Well, this is the one. This is our employee type. The next step would be for us to create a function that returns random IDs, because all IDs needs to be random, and we can do this with math.random, but let's do it with a more fine library from Node.js and also from browsers using the crypto module. Well, I will first import this, so here I'll say import in the top, and usually I like to do it like it's done in Python. First of all, I will just pass the path. We need to install something from the crypto module, and this is a built-in module inside Node.js and also inside the browser, so we should have no problem using this module. But for some reason, TypeScript gives us a warning. It tells us that it cannot find module crypto or its corresponding type declarations. And VS Code is also very kind to suggest us a solution. If I will press right here quick fix, it will suggest us to install @types/node. Let's do this. So here I will call npm install @types/node. Always when installing node packages, be very careful for typos. Well, I will install this, and now let's explore our files. Right here we have a new entry called node modules, and we have an @types entry. And now we simply have no JavaScript files, so no real logics, just these d.ts files, which represent like declaration files for our types. Now that we have these types, we can safely make the import from crypto, and we want to use the function random bytes. Yes, I also needed a from. Now that we have these random bytes, we can write our function that generates random IDs. So I wrote the function that generates random IDs, and we are returning a string. This is just executing this file, and this will return a random string. Now we need a function that generates employees. Well, I also wrote the function that generates employees. As you can see, we are returning a simple object, and we are receiving inside the function the employee name and the salary, and we are returning back an employee object. What we are doing right here, we are assigning the employee name to the name. For the ID, we are generating our random ID, and for the email, we are using something called string interpolation, and this is a very cool feature of JavaScript. Basically, using backticks right here on the top left of the keyboard, I can call anything inside my string right here. I can call all the information inside my string using this $ and parentheses syntax. This is a very cool feature of JavaScript. I love it. And for the salary, we are just assigning the salary. Well, we have our function. We can now create a few employees. Well, I created some employees. An employee called Peter, which has a salary of 100,000. Employee Dan, which also had a salary of 80,000. And I added these two employees to an array of employees at this point. Well, now that we have an array of employees, we can run a function for each employee. Well, and our function is called sendWelcome function, and this function receives a parameter of type employee right here, and it returns a string interpolation. Well, first of all, we are consoling log. We are sending this message to our employee mail. We are saying hello, and we are saying to our employee what salary he has right here. This is our send welcome message, and now let's iterate through each employee and call this message. Well, all we need to do is call the for each method, and here we are receiving an employee, and we are sending this send welcome message. Let's see how this is working, and let's execute this file. So here I will say, well, our function is working just fine. Here we are saying that we are sending these messages to these email addresses, and basically, yeah, a dump file. Well, our program is working just fine until now, but there's one more important point which I want to make inside this lecture. You saw that we are having these node modules and these types inside our node package. Well, what can we do in order to also generate ourselves some types? Because let's say that we are building a package to be used outside our project, and we also want to generate JavaScript files, but also maybe those who will use this package will also want to know about our types. Currently, if I will compile this file, you remember from the last lecture, if I call the folder, the TypeScript compiler, we have the dist folder. Now we have this new employee manager file, but you know, types are missing from this file. Well, is there a way in which we can also export these TypeScript files to be used outside our function, outside our package, like we are using, for example, the types for this function random bytes? And here you can see we are using, we have documentation on the fly. Of course we can. And to do this, we need to tweak a compiler option right here. If we open our tsconfig JSON file, at the emit entry right here, we have the option declaration right here. So if I will uncomment this, and I will set this to true, it will tell us that this generates d.ts file or declaration.ts files from our project. Let's do this, and there's a catch right here. I will show you in a moment. Well, if now I will call the TS compiler again, let me call this. Well, now we have also, aside from our JavaScript files, we have also d.ts files generated by the TypeScript compiler. But if I open this file, you will see this is empty. Why this file is empty? Very easy, because we are not making public our types. But if I will go back to our file, and for example, I will call export this type employee, and maybe export the create employee function. Maybe we want this function to be used outside our workspace. I call the export function. Now let me call this once again. And now if I open those types again, you will see that now we have these types right here. And the type is exported just the way we generated like this. This is exactly the same, but the function is exported in another way. It doesn't contain the implementation, it only contains the function signature. This means the function name, the function arguments together with the parameters, and the function return type. In order for this to not be a compilation error, we are using the declare keyword. This means we are just declaring how the function will look like in the future, and for someone who just want to use our function, for him to know what exactly is expected from this function. Well, using this dump simple practice project, we practice a little our types that we learned in this section, and we also learned about exporting declaration types from our project. We imported them and also we exported them using the export, using the declaration option inside tsconfig. Well, with this lecture we are reaching the end of this section in which we laid the foundation for our TypeScript knowledge. Let's move on into the next section of our project, of our course, and talk in more detail about more advanced TypeScript type features.